I'm in my Contoso cluster. As of now, you can find there's no services, no running task or no pending task. And the cluster is backed by one EC2 instance. If you go into the task definition, in this case my batch app task, I have modified this task to use small number of compute resources. If you select that, you can find that the amount of CPU units is 256 and the amount of memory I'm asking is 256 megabyte of memory. So for this lab, make sure that you set this configuration because we are going to run a lot of tasks in this cluster. So one vCPU is 1024 CPU units and quarter of a CPU is 256 CPU units. If you go into the cluster, you can find it is backed by one EC2 instance. So let's go into the cluster and then go under ECS instances. You can find the EC2 instance back in this. So if I select that EC2 instance and then look at what kind of EC2 instance that instance is, in my case, the EC2 instance is a T2 large instance. So here you can find it's a T2 large instance. If you go to AWS documentation and then select instance types, under T2 instances, you can find how many vCPUs are available under T2 large. You can find that it's 2 vCPUs. So one vCPU is 1024, provides 1024 CPU units into ECS cluster. So two vCPUs should provide 2024 CPU units to ECS. So one T2 large EC2 instance provides 2048 CPU units to the cluster. So if I go to the cluster and then under ECS instances, if you expand the scroll bar, you can find that how much CPU units are available in this cluster from this EC2 instance. So this one T2 large instance provides 2048 CPU units. So if you start new task, of course, those tasks will take some of these CPUs available and this number should go down. So let's start a few tasks. So I select the latest version from my task definition, which requires only 256 of CPU units. So I can run ideally about 8 of these tasks, maximum of 8. So let's start about 7 of these tasks under, let's say, bin packing. So run the task. It will successfully start those 7 tasks because the cluster has enough resources to start them. After a while, all tasks turn into running state, so they are all in good condition. So let's select the latest task and then try to run, let's say, 2 of these tasks. Again, you can select something like bin packing and then run the task. What you will see is that it will give you a warning saying that only one task successfully started and the other failed to start, because the cluster had only enough capacity for an additional one task. And what happened was the second task that you started failed because the cluster does not have enough resources. If you go to ECS instances and then observe like how many CPUs available, you can find that it has only 0 CPUs available. So the challenge now is if you try to run a service or schedule task, you don't know when those tasks will get started. Maybe there's a certain time period that you want to start certain tasks. So how can you scale this cluster to accommodate more of these tasks? So there are multiple ways you can do that. One is to manually scale the cluster. You can say, for example, I need 2 or 3 additional EC2 instances on this cluster. The other way is to do it automatically. So we will, in the next section, observe how we can scale this cluster horizontally and add more capacity. If you look at this Contoso cluster that I created, it was created by a CloudFormation template. If you go into CloudFormation, you can find the CloudFormation template that created this Contoso cluster. So in this case, I have EC2 container service, my Contoso cluster. So that's the CloudFormation template that provisioned this cluster. In that CloudFormation under resources, you can find that it created an auto-scaling group and a launch configuration. If you go into the launch configuration or the auto-scaling group, you can find some configuration it has put. So in this case, I went to the auto-scaling group, and it's a normal auto-scaling group that you find on AWS. So you already have auto-scaling features like schedule actions, scaling policies. Then you can go for activity history to see what happens during the scaling. So all the auto-scaling features that you find on standard auto-scaling is available for ECS. Before we do any scaling activity, let me first set the max number of EC2 instance under this scaling unit to 2. The reason being, when we play around with this, it's going to start some additional EC2 instances. So we need to set that max number to 2. So let me save that. If you want to manually scale this cluster, there are multiple ways to do that. One is to edit this auto-scaling group itself. You can do it either through console or through command line. So you can just go there and then add the desired count to something less than max, equal to or less than max number. For example, you can set it to 2. So that's one way to increase the cluster capacity. The other way is to go directly into the Contoso cluster, and under ECS instances, you can click this button called Scale ECS Instances, and then set the number of EC2 instances that you want. For example, you can set it to 2 from here, and then click Scale. What we'll see is that if you click this button, it will update the CloudFormation template that we just observed, and it's going to update the entry under the desired count. So here you can find that the desired count is changed from 1 to 2 because I did the update from ECS cluster. Let me reset all the changes I made here. So scale the cluster from 2 to 1. Click Scale. And so the scaling is successful. What will happen is if you go into the auto scaling group, refresh it, you can find that the desired and the max count is updated to 1. And right now, during that short period of time, it already started an EC2 instance. Let me terminate that instance, because what we are really interested is in auto scaling. This we did just to show you what happens if you manually scale the cluster. So I'm going to terminate the latest EC2 instance that was spin up by the auto scaling. So let me terminate that instance. So that is shut down in. To auto scale the cluster, select the auto scaling group created by ECS cluster. So this was created as part of the CloudFormation template. We already know that. So when you select it, under the scaling policies tab, you can find the scaling policies tab, you can add the policy. So when you add the policy, you can scale the cluster based on different parameters. So let's do not a normal scaling, but we'll do, let's say, stepwise scaling policies. To do a stepwise scaling policies, you can add this scaling policy based on steps. And what I'm going to do now is to give it a name for this scaling policy. Let's call it my scaling policy. As of now, I don't have any alarms defined. So let's create a new alarm. In this case, I don't want to have any notification sent when this alarm is triggered. As the initial one, I'm going to create an alarm when the average CPU utilization goes above 60% for at least one consecutive period of 5 minutes. I want to trigger an alarm, and the name of the alarm I'm going to trigger is called my custom Contoso alarm. So for the moment, I'm just going to create an alarm based on CPU utilization. Later, we are going to change it based on the number of CPU reservation. So I create this alarm. So this is a CloudWatch alarm that gets created behind the scene. And when this alarm is triggered, I want to add one instance when the CPU utilization is above 60% and less than infinity. Of course, you can do stepwise scaling. You can add extra steps. But in this lab environment, we are going to run only few EC2 instances. So therefore, I'm going to add only one extra EC2 instance when the CPU utilization goes above 60%. So we are going to give up some time for warm-up, 120 seconds. So far so good. So everything looks good. So let's create this scaling policy. So when I create this scaling policy, it creates a CloudWatch alarm. So if you go to CloudWatch and then go to the alarm section. So as of now, you can find there is one alarm defined. So this is the name we gave, my custom alarm. And this alarm gets triggered when the CPU utilization goes above 60%. So this is the initial alarm I created. I'm going to change this alarm to trigger not based on the CPU utilization, but based on cluster CPU reservation. So this is when the task starts and they ask for the cluster for additional CPUs. So select that alarm and then modify it. So under define alarm, so as of now, I'm based it out of CPU utilization. If you go to scale matrices, I can scale it on different matrices. You can even scale it based on some custom matrices. So in this case, I'm going to browse extra matrices and then scale this one based on ECS matrices instead of EC2 matrices. So under ECS matrices, if you expand that, you can scale this auto scaling group based on CPU reservation of the cluster. So remember, we are scaling it based on the cluster CPU reservation. We are not going to scale it based on service CPU reservation or any other utilization. We are going to scale it based on cluster CPU reservation. So what I'm going to do now is create a reservation. So here what I'm going to say is if the demand, the CPU reservation of the cluster goes above, let's say 50%, for a period of, let's say 1 minute, I'm going to trigger an auto scaling action. So there is an alarm, and when that alarm happens, I'm going to trigger an action. So this is how you usually do the auto scaling. So once I configure that, it says if the CPU reservation is above 50% for one data point within 1 minute, it's going to trigger this alarm. So far it's in OK state because my cluster is not doing cluster CPU reservation is in fact in this case 0. You can find that if you look at that graph carefully, the latest data points appearing is about 0. So in my cluster, you can find that as of now, there's no running task, no pending task, no running services because I stopped everything. So let me go into task and then start, let's say 2 tasks to bring the CPU utilization, sorry, the CPU reservation to 25%. So I'm adding 2 tasks. So it's going to request certain amount of CPU units, in fact 256 CPU units. So these 2 tasks going to increase the CPU reservation to 25%. So once the CPU reservation increased to 25%, it's still not going to trigger the alarm. So let them run in for a moment. If you go into the CloudWatch, after a few seconds and go to your alarms, you can find that it's still in OK state. because it takes some time for the this data to appear. So as of now, the CPU reservation is still under 50%. So if you keep refreshing, so these are old data points. So the new data points is where I have the mouse pointer. At some point in time, this CPU reservation is going to increase into 25%. So after a few minutes, I go into CloudWatch again. Let me check what happens to my matrices. So if I go into my ECS matrices, and then under the cluster name, I have my Contoso cluster CPU reservation. Select it. Seems like it is now increased to 25%. Yeah, so the CPU reservation is 25%. So the additional 2 tasks I started increase the CPU reservation into 25. And this still doesn't trigger the alarm because it's less than 50%. So you can find that the CPU reservation is 25%. Give it some time. If you are executing this lab, you will see it takes some time to get these the CPU reservation to 25%. Of course, I have edited this video so that you are not waiting to see this increase in the CPU reservation. So although the CPU reservation went to 25%, it still didn't trigger the alarm because I need to wait whatever the period that I have defined in my alarm to trigger it. So in this case, I am going to trigger it after when the average CPU reservation over a period of 1 minute is over 50%. So it doesn't trigger it. So let me increase the number of tasks running on this one, and then bring it to, let's say, instead of 2, I'm going to add some additional 4. So the total number of running tasks will be now 6. So let's add additional 4. So with the addition of these 4, the CPU reservation is going to go above 25%. So let's add this. So run the, so let's say you can run it under bin pack or balance spread, it doesn't matter. So this is going to start some additional 4 tasks, which will increase the cluster CPU reservation over 25%. Give it some time. All the containers started, or all the tasks started. And if you go into your CloudWatch again, you will still see that it's still somewhere around 25%. If you keep refreshing enough, after a few moments later, you will see that this reservation will go above 50%. So from the time it goes above 50%, it's not going to trigger the alarm. You need to at least wait that 1 minute period. So it takes the CPU utilization over that 1 minute period is above 50%, then only it's going to trigger the alarm. So if you, meanwhile, if I go into my EC2 instances, you will find that in the auto scaling group, I haven't configured it to have the max level, max number of instance to 2. So right now, even if it tries to auto scale, it's going to fail because I have defined the max count to 1. So it cannot add additional instances. So make sure that the max count is set to a number like 2. In this lab environment, we don't need to add a lot of EC2 instances. So this max number has to be the hard limit that you want to apply into this auto scaling group. So go to select the auto scaling group and then action edit. Make sure that when you are running this lab, the max number is set to 2, so that when the auto scaling action triggers, it will add an additional, it will have enough capacity to add an additional extra EC2 instance. So far so good. So if you keep refreshing, still it haven't triggered the alarm, although the CPU reservation now is above 50%. You need to wait for about 1 minute period where the CPU reservation is above 50%. So if you keep refreshing, at some point in time over 1 minute period, the CPU reservation will be over 50%, and that will cause the alarm to trigger. Keep refreshing. So now the alarm triggered, and you can find that here the CPU reservation went about over 50%, and it was in that situation over a period of 1 minute. So that triggered an auto-scaling group, auto-scaling event. So as of now, it's desired state 1. If I refresh this, you can find that the trigger of the auto-scaling event caused the desired count to go to 2, and it also started an EC2 instance behind the scene. So make sure when you are running this lab, the max is set to at least 2 so that auto-scaling can scale more than 1. So if you go into EC2 console, you can find that the auto-scaling has started a new EC2 instance behind the scene. So it's in initial state. At some point, this is going to boot up and then registered against the ECS cluster. So if you go into the clusters, as of now, there's only one EC2 instance. If you keep refreshing, after a few minutes, the new instance is going to boot up and going to register against this cluster. So you can find that the number of EC2 instance is now 2. And the running task is like before 6 tasks are running. If I go into my the cluster and then select ECS instances, you can find the 2 EC2 instance back in this cluster. The new one has 2048 CPU available. If you go into the CloudWatch and observe the metrics for the CPU reservation on the cluster, it's still at 75%. At some point in time, once you get the latest data points, this will go down because now the cluster has more CPU capacity than we had with one EC2 instance. After about few minutes, if you go to CloudWatch and observe the CPU reservation metrics of the cluster, the CPU reservation in my case has gone down to 37.5%. And you can also define scaling policies to reduce the number of EC2 instances on the cluster when the CPU reservation goes down. So for example, you can go to the scaling policies, edit it, and add a new scaling policy. So add a step 1, and instead of adding new instance when the CPU reservation goes over a certain %, you can remove EC2 instances when the CPU reservation goes below a certain level. For example, you can say remove one instance when the CPU reservation goes below, let's say, 20%. So you can define scaling policies like that to scale and scale out and scale in the cluster in the way that you like. So these are all typical auto-scaling features available for you. Let's do a bit of cleanup. First, select the auto-scaling group, select the scaling policies and delete it. So I delete the scaling policies. So there's no scaling policies attached to this auto-scaling group. The next step is to select the auto-scaling group, click edit, and then set the desired capacity and the max value to 1. So we are not going to run extra EC2 instance. After a few minutes, some EC2 instance will terminate. And if you look at this right now, there's only one two EC2 instances running, but they are not registered against the cluster. If you go to EC2 instance in a few minutes time, you can find that the one EC2 instance has already terminated and there's only one EC2 instance running. In this way, we are not going to run out of credits when we are executing these labs. I have stopped all running tasks. I have stopped all the pending tasks. There's no services running. There's only one EC2 instance back in this cluster. In this way, we can save some cost when we are executing these labs. You are now ready to go for the next lab.